What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph parabolas in standard form. And just to remind you, this is standard form right here. F of x is equal to ax squared plus bx plus c, right? Now, a over here, it's just a number. So if a is positive, your parabola opens up like that. And if a is negative, your parabola opens down like that, okay? And then the other thing to know here is this plus or minus, really, c at the very end. So this is your y-intercept. Okay, so remember the y-intercept is just wherever the parabola crosses or touches the y-axis. All right, so let's start with this one right here. F of x is equal to 3x squared minus 6x plus 5. Okay, so you can see we have a positive 3 right here, so that means our parabola is going to open up like that. And we have a positive 5 right here, or plus 5, right, for our c. So that means our parabola is going to cross the y-axis at y is equal to 5. All right. Now, in order to graph these, the first thing you need to do is find the axis of symmetry and the vertex. Now, to find the axis of symmetry, you just need to use this little equation right here. So the axis of symmetry is at x is equal to negative b over 2a. Okay, and remember you grab these a's and b's basically from your function in standard form, right? We have a, we have b, we have c, right? So here, same thing, we have a, we have b, remember to include the sign, and then c, okay? So our a right here, our b, and our c. Okay, so then x is gonna be equal to negative b, so b is negative 6, so we're gonna put a negative 6 on top, and that's over 2a, so 2 times a, which is 3. Okay, so then this is going to be equal to negative 6 over positive 6, right? Now, negative 6 divided by positive 6 is negative 1, so then this is equal to negative 1. And then a negative times a negative is a positive, right? So then we have positive 1. Okay, so then our axis of symmetry is at x is equal to positive 1. I'll just write it over here. X is equal to 1. Okay, and now we need to find the vertex. Okay, now to find the vertex, we can actually use the axis of symmetry, right? Because since we know that the axis of symmetry is at x is equal to 1, and the axis of symmetry also runs straight through the vertex, that means we know the x-coordinate for the vertex, right? So it would just be 1. Okay, but we also need to find the y-coordinate, right? So how do you do that? Well, all you need to do is plug in your x value to find your y, right? So we just need to plug in 1 into our function over here to figure out what y is, or f of x. So f of x is equal to 3x squared minus 6x plus 5, right? And then we're going to plug in this 1 right here and right here for the x's, right? So then this is going to be equal to 3 times 1 squared minus 6 times 1 plus 5. Okay, so 1 squared is equal to 1, so 1 times 3 is 3. So we get 3 minus 6 plus 5. 3 minus 6 is negative 3, so then negative 3 plus 5 is equal to positive 2, right? So then f of x, or y, is equal to positive 2, right? So our vertex is at 1, 2. Okay, so now we can graph this. So here's a graph. Boom! Okay, so we need 3 points to graph a parabola. So the first one we can use is the vertex, right? So it's at 1, 2. So 1, 2 is right there. The other point we can graph is the y-intercept. So remember, our y-intercept is at positive 5. So we're going to go 1, 2, 3, 4, 5. Okay, now to get from the vertex to this y-intercept, we have to go over 1 and then up 1, 2, 3 spots, right? So we can do the same on the other side of the parabola to find another spot. So we can go over 1 and then up 1, 2, 3 spots. So right there, okay? So then to clarify, this point right here is at 0, 5. This spot, the vertex, is at 1, 2. And then this spot right here is at 2, 5, okay? And then you just have to connect the dots like that. Okay, and the last few things we want to point out here are the axis of symmetry. So again, that's just a vertical line that runs straight through the vertex. So again, it's right here at x is equal to 1. And then we also want to find the domain and the range. So the domain is just your x values, your x limits from side to side, right? So For all your parabolas, it's always going to be the same thing. It's always all real numbers. Or you could write it as negative infinity to positive infinity, like that. And for the range, these are your vertical values or limits, right? So the range goes from right here at y is equal to 2 all the way up towards positive infinity, right? So we can say it goes from 2, we're putting a bracket because we're including 2, all the way to positive infinity. Or you could also say that y is greater than or equal to positive 2. All right, so hopefully that wasn't too bad. Let's just try one more that's going to be a little bit more complicated. All right, so here we have h of x is equal to negative 1/2 x squared minus 3x minus 4, right? So first thing you can see here is that our a number right here is negative, so that means the parabola should be facing down like that. And then our y-intercept will be at negative 4. Okay, but again, the first thing we need to do is find the axis of symmetry and then the vertex. So the axis of symmetry, again, is going to be at x is equal to negative b over 2a, right? So this is a, then negative 3 is b, and then this is c, right? So this is going to be equal to negative b, which is negative 3, over 2 times a, which is negative 1/2. Negative 1/2, right? So then this is going to be equal to negative 3 over 2 times negative 1/2 is negative 1. Okay, so then this is equal to negative. Now, negative 3 over negative 1 is positive 3, right? So then our axis of symmetry is at x is equal to negative 3, right? We'll write it right here. X is equal to negative 3. Okay, and then again to find the vertex, all you need to do is use your axis of symmetry right here and plug it into this original equation. So then the vertex is going to be at h of x is equal to negative 1/2 times x squared, but we're going to plug in our negative 3 right there. So negative 3 squared minus 3 times x, which is negative 3, minus 4. Okay, so then here, negative 3 squared is equal to positive 9. So then this is equal to negative 1/2 times positive 9. And then negative 3 times negative 3 is positive 9 also, so plus 9 minus 4. Okay, so then this is going to be equal to negative 1/2 times 9 is equal to negative 9 over 2, and then plus 9 minus 4. Okay, and then we can turn these into fractions by multiplying them by 2, so they have a denominator of 2, right? So then it's going to be equal to negative 9 over 2 plus 18 over 2 minus 8 over 2, right? Negative 9 plus 18 is positive 9, so then this is equal to positive 9 over 2 minus 8 over 2, and 9 minus 8 is equal to positive 1, right? So then this whole ugly thing is equal to 1/2, or 0.5. Okay, so again, this is the y value for our vertex. So the vertex, again, is going to be at negative 3, 0.5. All right, now let's graph this. So here's a graph. All right, now, again, the first point that we can plot is the vertex. So it's at negative 3, 0.5, right? So we're going to go 1, 2, 3, and then 0.5 is about there. The other point we know is our y-intercept, so it's at negative 4. So we're going to go 1, 2, 3, 4, right there. Okay, and then to get from our vertex to this spot, we went over 3 and then down 4.5 spots. So to get from the vertex to our other spot on the parabola, we're going to go over 3, right? So 1, 2, 3 to, this is negative 6 right there. And then down 4.5 spots to right there. Okay, so again, the vertex is at negative 3, 0.5. This spot right here is at 0, negative 4. And this spot right here is at negative 6, negative 4. Okay, so then we can just connect the dots like so, right? The axis of symmetry, again, is just a vertical line that runs straight through your vertex. All right, that's good enough. So then this is at x is equal to negative 3. And again, to find the domain and the range, well, the domain's easy, right? It's all real numbers. Always going to be the same thing. And for the range, it's going to be a little bit different. So here, the y values go from 0.5, right? So y is equal to 0.5 right here, and then down towards negative infinity. So we can say it goes from 0.5 to negative infinity, or we could say that y is less than or equal to 0.5. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.